Hello guys, welcome to my YouTube channel Learn to Code with Noob. Today in this video we will cover three topics which are very powerful topics in TypeScript. So first is lookup types, second is Keyof operator, and the third one is map types. So this is my continued part 9 in my TypeScript series. I have mentioned all the part links of my YouTube videos in the description below, so please check those out. And all the parts are in series, so they are in the continued form. So thanks for listening to our channel, and let's jump right in. Alright, so let's jump right into our another topic, which is lookup types. So lookup types is a very powerful concept in TypeScript, and it is a very powerful tool which you can use in TypeScript. So let me just clear the terminal first. So let's take an example. So for example, you have a type named as bank account, right? And in this bank account you have ID of the bank, name of the bank account, maybe you have an amount, and you have an address of this bank account, which has city, street, postal code. All right. So for example, you are writing a function, right, that update bank account, and you want to update the amount of the bank account. And for example, this function take the ID, right, and the amount. Now if you see, like, the ID and amount types, so ID type is string, amount type is number, like they are very simple types. So it makes sense to actually define that as a string and number, right? But we want to actually make sure, like, whatever, like, the type of the ID should be same as whatever the type is declared in this bank account type, right? We want to make sure that this is same. So for example, if for some reason the ID type is changed to number, we want to make sure that this ID is number, not a string, right? So one thing we can one thing we can do is lookup types. So uh, in lookup type, what you can do is you can actually say bank account, and in this you can provide the property. And what this will do is it will actually give you the type of whatever the type of ID property was in this bank account type. So if I hover over to this, so you can see the ID type is string automatically. And if for some reason I change this to number, we are making sure that this ID is number, right? Now same thing with the amount, right? So I mean, the other thing which we can do is, so for example, our requirement changed and we want to write a function to not update the amount, we want to update the address, right? So we are taking in the address now. So in order to actually define the type, either we can do is, I can just do like type bank account address, right? I can define a type alias, right, which basically is this, and then I will just say, okay, this is bank account address, right? So over here now I am making sure that my address is a bank account address, and if I hover to bank account address, it says my type is city, street, and postal. So for some reason will change this postal to number. Now this bank account address is not reflecting what the actual type of bank account address is, right? So if in order to make that sure, what we can do is this bank account and address. So now we are 100% sure like the address type is the same as the address type defined in this type, right? Now there are other possibilities too with the lookup types. You can there is also another name of this lookup type, which is index access types. So they are also called index access types. There are lookup types too. So there might be a question that why we didn't do this and why we did this. So one of the advantages is, so for example, if you're changing the type of one of the property, this takes care of that fact that the address will have the postal as a number, right? But over here the postal is still a string type. So there is one advantage of this, and the other thing is like you can use this for a third party thing too, right? So for example, I will just basically have a third party. I can say like a payment provider, can be Stripe, right? So payment provider.ts, and I will basically copy this whole thing over here, right? And I will just export this thing. So this is my third party payment provider, right? And I'm just importing this bank account from this payment provider. So now if I'm importing this type from bank account, right? So I don't want to like define these as my own types, right? Because if I am defining these as my own type, uh, the only purpose for that will be if I'm reusing these in any other places. So even if I'm reusing this in other places, the best way to do it will be like this, right? So that even if I'm reusing this bank account address and my third party address type changes, and then I know right away that this bank account address has been changed, right? So this is also one of the advantage which we have for this lookup types. And you can also have like you can do other fun things. So for example, if you want to have a type which is a union of ID and name, so you can have ID or name type, right? So what this will do is you can just do bank account, right? And you can have ID and then you can have name. So now your ID or name type can be string or number. So this is other way to actually access this. So yeah, so this is a short explanation what are lookup types or index access types in TypeScript. All right, so next topic in this video is Keyof Types. So this Keyof Types I have already explained in like a nutshell in my previous videos, but I just want to go into the detail because it is very important to understand this Keyof operator in order to understand the other concepts like map types. So just a small example of Keyof types. So for example, I have a type user over here, right? And this is Amanus user, which is basically of type user, right? So let's say the requirement is I need to write a function which function is like change value for key, right? And in that function, so what this function will do is the function main objective is to change the value for the supplied key, right? So, and whose value is going to change? It's that user object, right? So over here we will pass the object whose value is going to change, which is over here is user object, right? And I will supply a key, and then I will supply a value, like whatever the value which I want to change. Okay, so over here I will just say object whatever the key is, it should have a value whatever the value is supplied, right? So this is all fine, looks good, everything looks good. So now I will do that, like change value of key. We'll call this function. My object is minus user, and my key is name, and the value is like Bob. So now if I run I haven't did any console.log, but after that I will just do a console log and just see what is the value of this object minus user. So if I do this, so now you can see the name has been changed to Bob, right? So over here the name is minus. After running this function, the name is Bob. So this is all good, but somehow when I was doing the code, I just did a typo over here. So I changed it from key. The key is name actual, but I have mistyped it to name too. So now if I run this function, now what happens is the original name key stays the same, but I have added one more key value pair, right, which is incorrect. So in order to correct this, I can either do that, like I can either do like, okay, the key should be name and age and location, right? So now if I define a union type over here, union string literal type, if I do this, then it kind of works. So now it will complain because my union literal types doesn't have a name to in it, which is fine. But what if I have like 100 properties in this thing, right? So now if I'll do this, like whatever the 100 properties, if I want to define the 100 properties, it is not like a good solution. So fortunately in TypeScript, we can use the Keyof operator in this function. So what I can do is I can just say Keyof user. So now my key is the union type, like it is the actual thing which I have defined before, but this is a very short way to have that string union type in this Keyof thing. So what this Keyof thing is doing is basically iterating over all the properties, right? So now it's making sure that whatever the key I define over here, it is of strict type user. So if I do name 2, it will complain about it. Alright, so now this is about the Keyof. Now a quick implementation of the lookup types which we have seen in the previous section of this video. So right now my value is string, like I am passing the value as strings, but I might like pass the value like as 1. I can't pass 1 because I already have this as string defined, right? But what I did is like I have this now changed all to number. Let's say I did that, right? Let's say my requirements changed and I did it and I changed everything over here to number, right? I change everything to number over here, but my function over here is now string, right? Which I don't want that. So my function should actually reflect what are the values which are accepted by this object user. So the easiest way I can do it is I can take advantage of the lookup type. So in the lookup type, I can say that the value should be of type of whatever the key of is of user. So here is a good use of the key of and the lookup types use. So here what I'm saying is the value should be of whatever the types of user is, which right now is a number, right? So even if I change this back to string, right, then I don't have to change my function because it automatically takes that into account, right? So I did all of this as string, right? So automatically I didn't change anything in my function, but it automatically reflects over here and it's giving me the error, right? So a very good use case of how you can use Keyof. It is actually used in the advanced types like map types in TypeScript. Alright, so one thing I forgot while I was explaining Keyof types is, just for the sake of practice and revision sake, that we can actually change this method to work for any other type of object. So for example, so right now it is only working for, it is on, like, this function is only restricted for user type. You can make it work for any other object type. The way you can do it is, so for example, I have a new type defined as account, right? And I will have a account object which has a name XYZ and an amount $1,000, right? So now so how I can convert this or make it work for any other type of object is by using generics. So I can do type T, right, and place of user I can do type T. So basically wherever we have user we can replace it by type T, right? So now if I want to use this method for account object, I can use it, right? It automatically says, okay, you are using an account object, these are the keys which you can change. So I will say amount, right, and whatever the value I want to find, 2000. So yep, this is how you can use this thing method as a generic and make it work for any other object type. Alright, moving on to our next concept in generics world, which is map types. So these are one of the most, again, powerful types in TypeScript. It basically reduces type noise and copy paste type creations in your code base. So in shortly I will explain you what that actually means, like what I mean by type noise. So let's jump right in onto the use case. So for example, if I have a type, right, and let's say not a immutable, so I have a type which is mutable, right, and I have some properties in it, my repeated properties, name, age, right? So now I have a requirement, I want to change these types, this type, like the properties of this, to be immutable. So what I mean by immutable is, so for example, if I make an object, right, of type mutable, right, and I am basically like a name is, I don't know, so let's say I have this object like this, right, and I want to I don't want somebody to write the age like this, right, to write the value of age property like this. So on the initial creation of the object, for example, I have given some value, right, name and an age, but I don't want somebody else to write to this key later in the code like this, right? So basically this should error. So the one way you can fix it in TypeScript is to add a modifier in your property, and that you can do it like this. So you can just have a read only modifier. So you can add a read only modifier to your property, which basically uh, tells TypeScript that you can't write a value like this. So this is awesome. This is a perfect solution, which is totally fine. So in the same way, I also need uh, like the name property to be doing the same thing. So I can do this too, right? So this is totally fine. But if you see this thing clearly, like clearly we actually changed the original type properties. Like for example, this mutable, it was not read only, but we actually made it read only because our requirements change, right? That is totally fine. But what happens if my requirements changed and I have 100 properties in here, right? Let's say, can be a weird example, but let's say you have 100 properties defined over here, right? So so you have like a age, and you can also have like, I don't know, address or something like that, right? So there are 100 properties like that, and for each and every one of that you have to like write read only in front of that, right? And you are actually changing the original object, right? So the best way you can do it is with the map types. So in order to understand map types, you need to know Keyof and lookup types, which I have explained in this video, in the previous sections of this video, and that's the only reason I've explained them first. So so now what you can do is you can actually define a type, right, which is like a read only type, right? And in that, what you can do is in that you can just basically say, like, for every key in, right, name, age, right, and these all can be read only, right? And we know the return type of a mutable object is a string, so that's why we did it as a string. So now if I just replace this mutable by read only type, right, now I get the same behavior. And if you see, my read only type is basically the same thing, like read only name, age. But this is still not a good way to define the types, because we already know that there is a better way to define like a union of string literals, right? And the better way is to use Keyof. So you can basically say Keyof all the properties in this mutable, right? And now now if you hover over the read-only type, it stays the same, right? So this actually solves our problem of actually defining the read-only types, right? Defining the read-only properties for say 100 properties, right? And for example, if you do this, so for example, just remove read only from here, right? And if you are declaring your immutable type as a read only type, right? Now your actual mutable type stays the same, like it has the same properties and it is mutable. You can change name and age for a mutable, but if you want to have a immutable type and the only thing which you want to change is the is the requirement of that all the properties should be read only, you just need this map type and that's it, right? Now you can still argue that okay, now if I want this thing for any other object, right? So for example, if I have another type, right? What if I want the same thing for this another type? So for that, you can actually make this read only type generic, right? So here comes the beauty of generic. So you can actually say that you can actually define a type T which is generic now. So instead of mutable, you can just say T, and over here you can use the lookup types or index types, which I have already explained in the starting of this video, so you can check that out. And by lookup types you can just say so T index of key. So by doing this, now I can do this, right? So immutable dot, so if I just see what are my properties, age and name, right? If I do name, still doesn't lets me write that, right? Still throws an error. And now if you define any other type, let's say any other type, right, and it has the same properties, right, and it can have different properties, it's just for the sake of example I'm doing that. So if let's say if you have another type and you want to have an object of another type, but the only thing which is different is I just want this to be a read only type of another type, right? That's the only thing you want. Now another type dot address, if you want to change it, you cannot change that. So in this way you are not actually defining like more and more types, right? Your original types stay where they are, right? And you are basically mapping, like the way I understand this thing in my head is the reason why we say it as map types is we are basically mapping one object to another, right? So basically this mutable type is now converted to an immutable type, and that too only by this mapped type, right? We don't have to like convert the original object, you just mapped the original object to something else, right? Now now these map types, it used both of the operators. So one is the Keyof operator and other is the lookup types. So it used both of them, both of the functionalities. And now I also want to mention is that this read only type, this is actually already defined in the TypeScript. So if I basically say read only, believe it is read only, yeah, so read only, and if I do that, that is actually the same thing. So immutable dot name, you can say Actually, I will just remove it just to clear out the confusion. So immutable is of read only. It's not read only type, only read only. And if you see the actual implementation of that, it's basically the same how I did it, right? And if you notice that there are some other map types which are already predefined in the TypeScript. So one is read only. So what if you want everything to be optional? So you can do partial. So there is a partial type. So what that does is, now if I do like a dot in here, right? So you can see now age and name, right? They all are optional. So and they are not now read only. So they all are optional. So just by doing this as a partial, you basically mapped one object, one mutable object, to another immutable object, which is partial, like just by changing the properties to partial. Now there is another map type, which is pick. So what pick does is, you can define another type. In that you will, for example, if you want to say, okay, in this mutable from this mutable I just want to pick some keys in it. So let's say that key is only name, right? So now see, it doesn't let me actually add the age. And if I do this and autocomplete, I only access the name, not the age. So I basically picked one property from this. And you can actually check that out, how this thing is done behind the scenes, right, under the hood. So pick t, k extends of key of t. Extends I have already described in my previous videos what that does. So yeah, and there are also another map types too, like record. Yep, that's pretty much it from the map types. Thanks for watching, guys. If you like this video, please don't forget to click on the like button. If you don't like this video, please mention why in the comment down below. Like, share and subscribe. Keep learning.